Hi everyone and welcome back. So this is part 5 of the lithium ion cell capacity checker, and in part 4 I think I left off doing some wiring, and in particular I remember mentioning about these 3 yellow wires which were meant to measure different voltages at different stages of the circuit. Now the problem with these 3 wires is that these were actually providing power to the Arduino, and it's not a big deal in terms of functionality, but they're not meant to power the Arduino, and I don't really want them to because I don't know what negative effect that's going to have, so we need to stop that. But before I do stop that, I want to do some coding, so yeah, let's get started. Oh, actually, there's one thing that I've just remembered. Somebody said, I think it was last week or the week before, that if I increase the text size it'd be easier for you guys to read it. So I'll do that now. Let's say 18. Yeah, hopefully you'll like that. I don't know. So let me know if you like it or let me know if you don't, and we'll go from there. Right, now the first thing I want to do is to be able to read from the analog pins. So I'm going to define some pins. So we'll define, we need 3 of these, and they're going to be A0, A1 and A2, because if you remember rightly, we have the 3 yellow wires going into those pins. So A0 is the battery voltage pin. A1 is the, well, what should we call that? Preload, really. So preload voltage. Oops, I've written voltage again there. And A2 was postload voltage. Okay, so we've got the transistor pin, the battery voltage, preload voltage and postload load voltage. So I'll just save that, Control T, Control S, and let's get rid of that space. Okay. Right, the pin modes now. We need to set the pin modes. So battery voltage, preload voltage, postload voltage. Right, and these are inputs, input and input. Just as I'm writing this, I'm thinking, hang on, have I already done this in one of my previous videos? You know, one of the capacity checker videos. But I've just looked through them and I haven't, so I'm just wondering what is going on here. Maybe I've done another video that's similar. Anyway, so this is what we're going to do. So we've got the voltages set as inputs. Then we need another variable over here. We'll have well, not variable because we've not got any others, but we'll have float VPP, or you can say VPC, whatever, equals, this is 4.8 volts basically, but what we want to do is we want a factor that we can use to translate counts into voltage. I'll explain that more in a second, but it's 4.8 volts, but just to show you on a calculator, 5 volts divided by 1024 counts equals this in volts. So 0.0048, 4.8 millivolts. Right, like I said, I'll explain that in a second, but we're going to need it. Then, right, in loop, what we want to do here, right, we'll comment this out. If you remember rightly, what this does is, it this code here, it turns the transistor on and off so that we can allow the current to flow through the load. Anyway, let's get rid of this as well actually while we're here. Get rid of that and get rid of that. Now the next thing we want to do really is we want to print the values out to the serial monitor. So we need to set up serial here. So serial.begin 115200. What's happened there? serial.begin, Control T, Control S. Right, so we've got serial.begin, and let's say serial.print learn ready. That seems okay to me. So now over here we want to do, well, what we want to do is get these analog values and print them out as voltages. So serial.println right, so we want to do analog read the battery voltage. So we will read the battery voltage. Now, to start with, these are going to be counts. They're going to be displayed in counts out of 1024 counts. So 5 volts being read into the analog 0 pin would represent 1024. If it was 2.5 volts, it would represent 512, etc. Now, we're going to be reading about 4 volts, so 4 volts will be around about 800 counts. But anyway, let's carry on with that for now. So, preload voltage, so that's before the load, and postload, obviously, after the load. Right, so that's fine for the time being. Control T, Control S, and we might as well Control New as well, actually. Or should we? Let's actually write something else in here so that we know what we're doing. So I'll say here, let's say BV. That should be fine, BV. So battery voltage, let's say preload voltage and postload voltage. It's going to have to be like that. And then we're probably going to need to cast that as well. So put some castings in there, string, Control T, Control S, and finally Control, well actually one more thing, sorry, we do need to keep that delay. And I think we'll do one more thing. We'll put a break in here, so that will do, and then get rid of this. Control T, Control S, and Control U. So what I hope to get from this is we want to read those 3 analog values and we want to display them on the serial console, but we are going to get them as counts, so they are going to be values out of 1024. So we're not all the way there yet, but it's certainly a start. So let's see what happens. Okay, it's done uploading, so I'm going to press Ctrl Shift M to get the serial console up. And here you go, every second it's showing the voltages. Right, now this isn't going to be incredibly useful at the moment because remember we've actually switched off the transistor, and because we switched off the transistor there's no voltage flowing through this thing. Well, in fact, not only that, I've actually taken the ground wire out. So what I need to do now is I need to change the code again to turn the transistor back on every 5 seconds or so, and I also need to, of course, put the ground wire back. So first of all I'll change the code. So digital write, let's see, let's just write high from the setup. Obviously you wouldn't keep it like this because there are lots of different control procedures you'd want to do, but if I just upload that, basically what this says is start the drain straight away. As soon as the Arduino starts up and it initializes, then start draining the battery straight away, and in the meantime just print this every second to say what the voltage is. That will do for now. It's fairly simple. Okay, done uploading. Let's do this again. Oh, and of course I need to put the ground wire back in. 1 second. Okay, the ground wire's back in now. Now let's have a quick look at these values. So we've got 790-ish That's the battery voltage, and then before the load we've got 690, and then after the load we've got 357 or 350. And that makes sense because each time it passes something, a load, it will decrease. So that makes sense. But now we need to change these counts or points, whatever you want to call them, into voltage. So let's go back to the code. So what do we want to do here? We want to get the amount of counts, and we want to basically multiply them, it's really this simple, by the voltage per point, which we already worked out earlier. So put that there, put that there, put that there. Now this may kick off about something, but we'll see. So Control T, Control S, Control U. And let's see if this works. So it's done uploading, Control Shift and M. So this is the amount of voltage now. Well, apparently anyway. So battery voltage 3.85 volts or 83 or whatever, 3.4 before the load, and 1.75 after the load. So we need to go a step further now. We do actually need to check these with the voltmeter, but let's go a step further first. So let's go back to the code, and what we want to find is the voltage drop across the resistor. So we need another variable, so we'll say float, what should we call this? V drop, I suppose. V drop. So float V drop, and over here we want, yeah, it should go about here. Right, let's have another variable here. So float BV equals this here. Float BV equals that. And then here it's going to be BV. Now we need another variable, which is this preload. What is it? Preload voltage, and that's this value multiplied by VPP. Let's just shove this in here, and we need the post load as well, so copy this one more time, and this is post load, so post load voltage, and that variable needs to go there, and that needs to go there, like that. Okay, so we've just tidied that up slightly. Now over here, this V drop, it doesn't actually have to go there, it could go here, and likewise these could go there. It just depends on what you're trying to achieve really. But anyway, V drop equals the preload voltage take away the post load voltage. That makes sense, doesn't it? So the drop across the resistor is the voltage that it was before the load, and then what the voltage was after the load. And then we want to print that to the serial console as usual. Control T, Control S, V drop, it needs to go here, and oops, V drop. There we go. Oh, actually, just one more thing as well. I'll put a space there, and I think we're ready to re-upload. Yep, looks good, and it's done. Control Shift M. Right, so we've got the battery voltage before, we've got the preload voltage, you've got the post-load voltage, and we've got the voltage drop across the resistor. So let's go a step further now, again, and we want to work out the amperage now in the whole circuit. So let's put another variable in here, so we want to do, well, let's just say amperage, keep it simple I suppose. Now amperage, just put another space there, amperage equals, well this is Ohm's law, so amperage equals the voltage drop divided by the resistance of the resistor in question, which is, if I remember rightly, it's 1 ohm, is that right? I'll go and check. Yeah, it is 1 ohm, give or take though. It's got a tolerance rating of J, which I'm not going to go into, but it's 1 ohm. So, so amperage throughout the whole circuit equals the voltage drop divided by 1. Control T and Control S. Right, we also need one of these below here, and amperage is amperage. Control T, Control S and Control U. Let's upload this again, and when this is done we've reached a milestone. Okay, so that's done. Control Shift M. So now we've got the battery voltage before, we've got the preload voltage, we've got the post-load voltage, we've got the voltage drop across the resistor, and we've therefore got the amperage. Now it's a little bit silly really, but it just works out that because the resistor is 1 ohm, it makes it very easy. But this code that we've put in place here, if you were to change the value of the resistor, this would work perfectly. So obviously over here where I've got voltage drop divided by 1, you could actually write voltage drop divided by the resistor resistance. So yeah, just in case you guys want to do this, I think I'll add another one here. So float load, I've got to be careful the way I word this actually. Now let's say resistor resistance. Resistor resistance, that's a bit crap in it. Let's just say load resistance. Load resistance equals 1. So whatever the resistance of your load is, put that there, and then let's just change this and we'll paste that there. Control T, Control S, Control U, and it's done. Control Shift M. Okay, and it's of course the same because I've put 1 in, but that's better coding, isn't it? Because if you want to add your own resistor, you can just change the value and it'll be fine. So anyway, we've got the voltage, preload, postload, voltage drop, and the amperage. So that's the first step complete. So yeah, what we'll need to do next, probably in the next video, because this is already a very long video now, we will need to check the voltages are right. And it's possible they are not perfectly accurate, and the reason being is because the actual Arduino is referenced against a certain voltage, and if that reference is not what we expect it to be, and sometimes they're not, then it's simply not going to work perfectly, but it'll be close enough anyway, but you know, whatever. So yeah, we'll need to check that in the next video. And like I said earlier at the start of the video about the 3 wires powering the Arduino, that shouldn't happen. But what we'll need to do probably in the next video is either make it so that we can disconnect the ground wire from the battery in order to prevent it powering, or the other thing we could do is put resistors in series with the 3 yellow wires. But the problem is with that, and the reason why I did this code first, is because if you go too mad with the resistors, it will mess up these values and it will make them lower, and of course we don't want that. So yeah, anyway, I hope you enjoyed this video. I certainly enjoyed making it, and thank you for watching, and see you again soon.